I don't, for what it's worth.
Is it amino acid?
Interestingly,
Right, many of these things have.
So it was very beneficial for...
My name is Matt Caberlin, and welcome to the Optispan podcast. Hey everyone, welcome to the Optispan podcast. Today we're going to do something a little bit different, so we'll see how this goes. I understand that Nick has prepared a video from Bryan Johnson that we're going to watch together and respond to sort of in real time. Just as full disclosure, I'm not a follower of Bryan Johnson. Every once in a while, some of his stuff kind of comes across my radar, but I really have not paid a lot of attention to what he's doing or what's going on. So just to kind of put that out there, I don't know a whole lot about the details of his protocol or any of that stuff.
Yeah, so a bit of context on my end is I've always watched videos like this, and now that I work here, I have a voice in the back of my head of like, what would Matt think about this video? So I've got probably 6 more videos like this from other creators that I just would love to play for you and get your opinion on. So
okay, we'll see what happens.
Here we go. Let's watch it.
I'm traveling to a remote island for an extreme medical procedure that could change the future of humanity. Humans have a 120-year ceiling, and so far, no one can punch through it. Gene therapy might be the answer. This is a journey in search of the fountain of youth.
All right. So do you want to give us a quick overview of what gene therapy is?
Sure. Yeah. I mean, so gene therapy is a pretty broad term that really refers to the use of any exogenous genetic material that you put into a body to change the expression of a gene and ultimately a protein. So what I mean by exogenous, right, is you're taking DNA, typically, could in principle be mRNA, like the mRNA vaccines. You are then usually injecting that into a person or an animal with the goal of typically increasing the expression of the mRNA, which then gets turned into the protein. So, but really it's a catch-all, and there's a bunch of different technologies that can be put under that term gene therapy. I think what most people are familiar with is permanent modification to the genome. That's kind of how gene therapies started. The idea being, there are these typically rare inherited disorders that are caused by a specific mutation in a specific gene. And there are ways to go in and change those mutations in at least a subset of cells and tissues. And the hope would be fix, whatever the disease is that's caused by that genetic mutation. More recently, there have been a bunch of different types of gene therapies that have been developed that are not necessarily permanently modifying the entire genome, right? Where you can transiently turn on, in principle, turn off the expression of genes using different types of gene therapy.
This is me as a kid. This is a kid who was born with one of the effects of the gene therapy I'm about to do. In mice, when they received this gene therapy, they lived 30% longer. Let me back up and tell you how we got here.
Follistatin.
In the shadow of the Caribbean lies Roatan, a hidden gem off the Honduran coast, shrouded in mystery. Beyond its breathtaking beaches and coral reefs, Roatan hides a secret venture, Prospera, an
Not so
experimental
secret.
zone for governance.
All this that you see is Prospera.
All right. So my next question for you is, why is this being done on a secret island and not here in the U.S.?
Probably because it would be illegal to do it here in the U.S. So the FDA regulates obviously all sorts of medical interventions, and the use, again, I'm guessing, of a follistatin gene therapy would be illegal in the United States because it hasn't been approved for any indication. So this is pretty typical in medical tourism. They go somewhere where there are fewer or no laws to get around scrutiny of regulatory bodies like the FDA.
Could you see it eventually becoming legal here, or hard to say?
Sure. I mean, in principle, if the therapy was to go through the typical clinical trial process, demonstrate efficacy and safety, absolutely it could be approved by FDA.
I'm traveling to the heart of Prospera to find Minicircle, a biohacking company rewriting the rules of wellness.
So I do know this company sort of in passing. So one of my former graduate students actually reached out to me. This was probably a year ago now, because he had started working in this company and just sort of wanted my my thoughts on what they were doing, and their future. So I'm kind of familiar with the technology that they're using, this Minicircle idea. So this is, as I was alluding to earlier, sort of one of the newer types of gene therapy that have been developed. The Minicircle, if I understand correctly, refers to the fact that typically when people in the laboratory want to what's called transgenically overexpress a gene, you would put the gene into a cell on a circular piece of DNA called a plasmid. And then that circular piece of DNA can either integrate into the genome or it can be carried what's called episomally outside of the genome, and the gene can be expressed off of this circle. So the reason why I'm going into this is that these plasmid DNAs, because of the way that they are purified, they're usually purified from bacteria. So they have a lot of bacterial DNA sequences in there that are used to grow up large amounts of the plasmid in bacteria. The Minicircle technology allows you to excise that bacterial DNA to make a smaller circle. That's where the Minicircle comes from. So the idea there is that you're less likely to have sort of off-target effects in terms of inflammatory response to the plasmid because you don't have all this extra sequence that you don't need to achieve the goal of expressing the gene inside the cells of whatever organism you're putting it into.
I'm curious what advice you gave your grad student, if they took it or not, or...
Yeah, well, I mean, my advice really was around more general principles. So I don't know a whole lot about the people involved with this company. I've never heard of them before when I looked at the materials that he sent me. So I don't know anything about the individuals. My advice was more general that, usually the type of people who are involved with a company like this that tries to skirt the FDA regulations often don't have a lot of experience, often are, not the people who would, they're not going to be the people who are part of the typical sort of biotech pharmaceutical world. There's good and bad associated with that, but that you have to be careful, right? Because it really comes down to the integrity of the individuals. And in general, and again, this is nothing specifically about the people at this company, in general, it's been my experience that people in this space who tend to operate outside of the law are just a bit more questionable in their ethics and their approach to science. And the concern would be that the quality of the work that's being done is not going to be up to the standards we would expect in a more regulated environment.
Their target, follistatin gene therapy, a pioneering technology with the potential to improve muscle and strength, slow the speed of aging, and many more benefits.
My name is Walter Patterson. I'm one of the founders of Minicircle. Me and Mac founded it. We wanted to do something impactful. We wanted something that would be impactful for most people's lives.
This quick question there is, what he says is great. He wants to impact a lot of people. I mean, so do we. But obviously the cost right now is $20,000. What would it take if this was something that is advantageous to bring that price down and make it where you could scale it?
Well, I think there's a few things to think about. Like, one is the technology itself and how much does it cost to actually prepare, the material that they're using in their protocol. The other is the regulatory piece, right? So I don't think you would ever get a widely used therapeutic, at least in the current environment, until it goes through the FDA regulatory approval process. So independent of price, the availability of the therapy to lots and lots of people requires almost that it goes through that process. And that's a very expensive process. So I don't know exactly what the numbers are, but pharma companies will tell you we're talking tens to hundreds of millions of dollars to go through the phase 1, phase 2, phase 3 clinical trial process. So it would be a very expensive process just to get that piece done. I think actually the materials preparation, that's all scalable. So I don't think that actually would be very expensive. Again, I mean, just if you look at like the mRNA vaccine technology that got rolled out during COVID, the cost of that came down quite dramatically as scale went up, right? And obviously there were government subsidies and everything else, but still relatively inexpensive therapy, and I suspect that you could get there with this this type of modality as well. So I think it's really on the regulatory side where most of the costs would come in. Of course, the value of that is that you learn something more about efficacy and safety, which I don't think we have any information on right now.
Yeah.
And of course, you'd want that before you start recommending this to lots and lots of people.
Do you think that mRNA technology could be used for this field?
Absolutely. No, there's no question that you could use those sorts of transient mRNA expression approaches for other types of interventions. I haven't really heard a lot of people talking about that. There's also the vaccine side, right? So we covered in an earlier episode on the podcast one of the papers that has talked about developing a vaccine that targets senescent cells. Now, there were issues with that paper, but I think conceptually that idea makes a lot of sense, and you could absolutely use that sort of mRNA vaccine technology that was used for COVID-19 to target other proteins and potentially to target senescent cells or other things that you might want to clear out as a consequence of aging and use the body's own immune system to do that. So there are definitely applications of that kind of technology that could be useful for increasing health span and potentially lifespan.
In therapy because it seemed too risky. If a therapy caused, say, cancer in my body, there'd be nothing I could do to reverse the process. What makes Minicircle's therapy different is that it has a built-in kill switch.
So, I mean, that makes no sense. So what he said was, the reason why he didn't do gene therapy previously is because if something went wrong, there wouldn't be anything that you could do about it, right?
Mm-hmm.
But this new kill switch technology alleviates that problem. And he used cancer as the example, but if you've already got cancer, it doesn't matter if you turn it off at that point because you've already got cancer. So that's kind of nonsensical, at least that example. I think the larger idea that being able to turn off the gene that you're using in your gene therapy makes sense. And that's one of the criticisms I've had of gene therapy in the past is these technologies that permanently modify the genome, you can't really stop the therapy like you could if it was a small molecule, just stop taking the drug, right? So this is a nice advance on that. I'm not sure exactly what the technology is they're using here, but the idea that you could shut off the expression of the gene does, I think, alleviate that concern. It doesn't fix the problem if you've already created something like cancer or permanently damaged your kidney or your heart. Shutting off the gene at that point isn't going to help necessarily. It might prevent it from getting worse, but there's still. So I think it's an improvement, but the idea, it's a little false sense of security here, I think, that maybe he doesn't understand biology well enough to appreciate that doesn't mean it's safe just because you can maybe shut it off. Then there's the question about how effective is the kill switch, actually. That will depend on the technology they're using.
It's interesting to hear it's actually a plausible mechanism, though, like kill switches in general for this sort of...
Oh, yeah, there are all sorts of what people call inducible promoters, right? Or repressible promoters. So the idea is the promoter is the sequence of the DNA that comes before the gene, and that is a major determinant of how highly the gene is turned on or turned off. And there are a variety of mechanisms people can use to turn up or turn down the expression of a gene. Usually you would add a small molecule. So like the classic example of this that we used a lot when I was doing yeast work is something called a TET on or TET off promoter. So that's tetracycline on or tetracycline off. So you add tetracycline, it binds to a protein that then turns the gene on in a TET on system. In this case, if it's a kill switch, that would be a TET off system. You add tetracycline, it binds a different protein that comes and turns the promoter off, and that shuts down gene expression. So those are well characterized in a bunch of different systems. They aren't perfect. They don't. They're what are called leaky systems, meaning that you're never fully on or fully off. But it definitely can help you control the amount of expression you're getting from these promoters. So I'm assuming this is some similar kind of technology to that.
So it's more of a dimmer switch than
I think
switch.
That's a fair characterization.
Can you think of an example where it would work? Like obviously cancer is a bad example. Can you think of a better one, maybe in yeast or?
Well, I mean, I think they work again in the sense of it does allow you, I mean, you could make the same argument about a small molecule, right? If you take a small molecule and it causes you to get cancer, you stop taking it at that point, you still have cancer, right? So again, I think I'm not suggesting that it's not a benefit to have the ability to turn the gene down. What I'm suggesting is the way he presented it gives a false sense of security, as if this is a safety mechanism, right? And the reality is things can still go off the rails with this kind of a technology just because you can potentially turn it down. First of all, you can't turn it off. That's just not biologically, at least as far as I know, there is no repressible system that is 100% off. And secondly, if you've already caused damage, it's too late to do anything about that damage just by turning the expression down. So it was just more the way he presented it, as if this now makes it safe, right? Which is not true.
Which might have been how it was presented to him.
If my body reacts badly, I can take the antibiotic tetracycline.
Oh, look, it's tetracycline.
And deactivating the DNA molecules I've been injected with. This treatment is not FDA approved in the US, which is why I'm traveling all the way to Prospera.
Like I would imagine, as a fellow entrepreneur, the joy you must feel when someone lands and like...
This feels almost like a marketing thing, right? I mean...
Like almost like a sales pitch?
Yeah, like, I mean, I have no idea. First of all, this isn't new, right? I mean, this was like, I heard something about him doing gene therapy like, I don't know, 6 months ago or something. So, but
yes, he talks about the date in this video, I believe.
This video is recent though, right?
The video is recent, but he did this back in mid-2023.
So, I mean, it just, I don't know, maybe I'm wrong. It just feels kind of like this is a marketing thing for these guys. And
what's interesting though, it's Bryan so well off that I feel like he doesn't need money from them. So I'm curious where his incentive is in this. Yeah. And we don't have to include that, but.
No, I mean, I think it's fine to ask the question. I mean, so maybe at the end of the video, we can talk a little bit more about that.
Sam Altman heard about it, offered us some money, and we started a company. The effects of it.
I mean, that's kind of interesting, right? So I don't know. I mean, again, this feels a bit like, I don't know anything about Altman's involvement here. I suspect some people watching this, that will make them feel like this is a more credible operation.
Co-signing it.
Yeah. It would be interesting to hear from Altman what his actual involvement is with this company.
Incredible that we've seen it. Big muscle mass increase.
All right. So let's talk about this graph. So I believe.
So this is they're claiming that these are effects that they have seen with their clients, I'm guessing. Change in, I mean, again, we've talked about biological age. I'm assuming here it's an epigenetic test. That is not biological age. It's one metric of epigenetic changes that occur with age. And they are claiming that they have seen a very large decrease in epigenetic age. Again, do you trust these people? I don't. But if you do, okay.
So this is the age of the participant, and this is how many years they improved.
Yeah.
Hypothetically there.
But again, I've said it before, like science should not be done on YouTube. There is absolutely no reason to trust these people. They're trying to sell you something.
Yeah, fair enough.
Genetic age, and we're even seeing some lengthening of telomeres in some people.
And so that, I mean, again, lengthening of telomeres, is that a good thing or is that a bad thing in the context of aging? I think there's people who would argue both sides of that. Certainly shortening of telomeres in the immune system is associated with higher all-cause mortality, probably reflecting some level of immune senescence. Increasing telomeres in other tissues is a pro-cancer mechanism. So telomere shortening is an anti-cancer strategy that cells use. And one of the ways that cancers can escape that is by artificially extending their telomeres. So, you know, I think it's probably a reflection of something good, but it could also be a reflection of something bad.
Do you think because telomere shortening is a hallmark of aging, that's why maybe they're talking about it, or that's why people want to lengthen them?
Well, I mean, we haven't talked about the evidence for follistatin yet. In the paper that looked at follistatin gene therapy for longevity, they also saw extension of telomeres in mice and combined it with telomerase gene therapy that extends telomeres and reported a larger extension of lifespan in mice. We should probably talk about that paper. Maybe now is a good time, because I think, you know, one of the questions here is like, what is the actual evidence that follistatin gene therapy would be beneficial. And in the context of longevity, to the best of my knowledge, there is a single paper, one. And that paper has been pretty roundly criticized as having some significant flaws. One of those flaws being that there were only like 8 mice in the longevity experiment. And just to give people a little bit of comparison, in the interventions testing program, for every intervention, there's more than 100 mice. So that is a massively underpowered longevity experiment. So that's one issue that's been brought up about that paper. Another issue that came out after the paper was published is that one of the figures was duplicated. So they had to put out a correction. And then they had to put a second correction because some of the conflicts of interests of the authors were not disclosed in the original paper, that they all, had financial associations with a company that's developing gene therapy. So none of that is to say that the paper's wrong, but there's one paper reporting a lifespan extension from follistatin gene therapy in mice, only one, and it's got some limitations, I think is fair to say. So if you compare the evidence for follistatin gene therapy as a longevity intervention to other things, it, is way down the list, I think, in terms of reproducibility, robustness. It just hasn't been, nobody's reproduced it. I'm not saying it's not reproducible. I'm just saying nobody's reproduced it yet. And he said something about how it's the seventh highest ranked intervention on his list, I guess. Again, this is where, we've talked about the challenges or the problems with using percent lifespan extension as a metric, right? So in this particular study, the controls were short-lived. So yeah, they claimed that there was like a 30% increase in lifespan from follistatin, but that's because the controls were short-lived. I think again, I'd have to go back and look at the paper. I think the absolute effect from follistatin, the follistatin treated mice lived, I think it was about 33 months, which is about 1,000 days. So you would typically expect the controls to live about 900 days. So that's closer to like a 12, 13% extension if the controls were where they would be expected to live, not a 30, 40% extension. So again, my take is follistatin probably increases lifespan in mice, but I would not be surprised at all if it doesn't. And if when people try to reproduce this, they aren't able to reproduce it. To my knowledge, that's the only evidence that this gene therapy would promote longevity, period. And I think the human epidemiology is kind of mixed, right? Like there's at least one study that suggests that it's correlative, right? But that follistatin expression in people is associated with poorer pulmonary function. So again, when you try to balance the risk reward, I just don't think there's a ton of evidence yet for reward. Now, the body composition changes that you might expect to see in terms of increased muscle mass, you would typically think of as a positive change. And I'm sure that's real. Like we know that's one of the things follistatin does. But I think the longevity, piece here is probably lacking in data.
It's been interesting seeing the whole supplement industries pop up or companies pop up just with the foundation of one study.
It feels to me a little bit different when it's a supplement. I mean, I agree with you. Like I certainly have gone on record saying you should start taking a supplement based on one study. It's a little bit different, a supplement versus a gene therapy though, right? Because a gene therapy where you go to some island, right, is a whole different beast from taking a supplement, right? That at least if people are following the law is going to be manufactured using good manufacturing processes and things like that. So.
All right, here we go.
This could be the most powerful anti-aging therapy I've ever received.
Yeah, I doubt it.
To say I'm excited and nervous.
And so what would you say is his most powerful anti-aging?
Well, I don't know everything he's done, right?
Okay.
So I was sort of listening to that list going, okay. So I don't know. I mean,
earlier in the video, he said this is ranked 7th. What do you think his top ones
Well, I mean,
are?
obviously the things that are going to move the needle are eating a healthy diet, exercising regularly, getting good quality sleep, right? So those, I'm sure, of the things that he's doing are improving his health if he's doing them well, which everything I understand is biomarkers have gone in the right direction. So those are probably the things that would have benefit, right?
Yeah. So there's somebody who's not doing those things And even if this was beneficial, you wouldn't even consider it probably until
Well,
you were to.
I wouldn't say that. I mean, again, I think for most people, modifying the lifestyle factors is the biggest bang for the buck, right? Or the lowest hanging fruit. That doesn't mean that pharmacological supplements, maybe even gene therapy, can't have benefits in those people. Typically, those benefits are going to be smaller than what you would get from modifying lifestyle. Now, the one counterexample you might point to are things like the GLP-1 agonist, which actually help you modify the lifestyle factors. But I do think that certainly for most people, it makes sense to start with the things that are going to give you the biggest benefits.
I see.
This therapy could have huge implications, not only for me, but for all of humanity. Will it help me break that 120-year ceiling? We'll see.
Well, we're not going to know for like, I don't know, how old he is, 60 years, 70
He's
years?
like 46. Yeah, we got some time.
Indecision because there's no stat. That's it.
Thanks, Doc. Clean injections.
Yeah, good.
What's that?
It's humanity's only objective.
Did you just get a step closer?
We got a step closer today.
Yeah.
I am
Any
now
opinions on that? Only
officially,
objective?
Genetically.
Well, I mean, so look, I think, I don't know. I guess my gut reaction is that if that's your only objective, you're living a pretty shallow life. But that's my personal opinion. But the part about getting a step closer to that for humanity, I mean, I think there's very little chance that this is actually part of the long-term solution, in my view. Not that gene therapy couldn't be, but that this particular gene therapy. Yeah.
Human.
All right, let's look at it.
So follistatin increased by 160%. Yeah, I just don't know enough about what the typical expected levels would be for a male of his age. But I mean, okay, so this would suggest that the gene therapy was effective at increasing follistatin levels. We haven't really talked about what follistatin does. That's probably worth doing, right? So follistatin is an inhibitor of a protein called myostatin. Myostatin suppresses muscle formation. So because follistatin is an inhibitor of myostatin, you would turn down myostatin. That you would expect to see then increased muscle formation, a change in body composition towards higher lean mass, and that's well established. Like I'm quite confident that this gene therapy, if it's effective in most people at increasing follistatin, would lead to more muscle synthesis. And we know from animal studies in the laboratory that increasing follistatin expression will lead to more muscle, as you'd expect. That can be beneficial in mouse models of muscular dystrophy. I think there's also some evidence that follistatin can have beneficial effects on glucose metabolism. Again, that's what you would expect with higher lean mass, but even independent of the lean mass effects, there's some thought that follistatin can improve insulin sensitivity, glucose homeostasis, and have positive effects against obesity. So there is some reason to believe that at least for certain conditions, increasing follistatin, probably transiently, you probably wouldn't want to do it continuously, but transiently could be beneficial in terms of positive change on body composition. Again, to the best of my knowledge, that's about the extent of the evidence that follistatin is beneficial in laboratory animals. And then there's the one longevity study that I pointed to. I think what we really don't know, and I should say that study where they reported increased lifespan was an adult onset, I think it was intranasal follistatin. They may have done both intranasal and IP injected follistatin gene therapy. So what we don't know really is what the long-term effects of overexpressing follistatin would be. So there is some reason to believe that this could be beneficial from a body composition perspective. I think the question about what the long-term risk-reward looks like remains to be determined, and we can come back to that.
Yeah, he made a joke about picking up the car, but I've always kind of viewed like our muscles have a governor on them, so we don't overexert ourselves and tear a muscle or a ligament or something. Do you think there's any chance that if you were to inhibit myostatin, you could potentially get increased muscle mass to the point where you increase the probability of injury?
Oh, absolutely. And I mean, again, I think that's not going to be unique to follistatin, right? I think anything that preferentially increases muscle mass, maybe muscle strength without corresponding improvements in ligaments, joints, bone, right, could predispose you to injury because your supporting materials aren't going to be able to withstand the stress that's put on by exerting the muscles to their maximum potential. Yeah.
Because the muscles go up quicker and then the bones and ligaments can't keep up.
Right.
Okay.
Right. Again, I don't know that's the case with follistatin. I don't even know if people have really looked at that. But in general, things that would just specifically increase muscle mass and function could have that effect.
I could be wrong, but I've heard the cows are pretty unhealthy. I mean, they look really big and muscular, but they're short-lived.
Absolutely, yes. And I mean, I think this is the difference as well. Those animals have an inborn mutation, so they go through development. So they go through development and all of adulthood with high levels of follistatin. So that is not a pro-longevity strategy in that context. I think the question is this sort of approach where you turn up follistatin maybe transiently during adulthood a pro-longevity strategy? That's a different question. Again, very little evidence to support that, with the exception of the one mouse study. And again, to me, that's why it just seems really premature to go right to gene therapy for this thing, right? I mean, again, when you think about this from a risk-reward perspective, like the rationale where there's one not very high-quality mouse study on the plus side, and a bunch of questions about safety on the minus side. And we've talked about, does the therapy work? Even if it does, what are the negative consequences from high levels of follistatin? We just talked about injury as a potential one. There are a bunch, right? There's all sorts of unknowns just from the potential downsides from increasing follistatin expression. Then there's the questions about the company itself, the technology they're using, the manufacturing and purification processes. To me, that's the real red flag here. And that's the real concern about this medical tourism going to these, secret islands, right? You really have very little information about the quality control that goes into the purification of the products that are being used. It's the same thing's true with some of these stem cell therapies that are done offshore as well. So what are they actually putting into your body? You really have to trust them, right? How was it purified? And look, I've even in the best labs in the world at the most reputable institutions, I've seen some pretty bad plasmid purifications, right? So, one of the things, and look, I'm not a huge fan of FDA, don't get me wrong. One of the benefits, though, to go through the FDA process is that they require companies to follow good manufacturing processes, good clinical processes, to high standards, right? You don't have that with these sorts of offshore organizations. And so you have to trust them. And so the question is, and this is what I would pose to people, like I have no idea where he's getting his advice from, but after watching this video and seeing it, like, ask yourself, do you trust these people enough that you trust them to do it right, to make sure there aren't any impurities and to put this stuff in your body? That's independent of whether the therapy itself has a positive risk-reward profile, right? This is a completely different question. And I will say, I mean, I think, again, I personally would be in favor of a way that these types of therapies could be offered in the United States with some regulatory oversight. Like, I think this has been a big problem in the stem cell therapy world, right? Because the FDA has just said no, right? You have a lot of people going offshore to get these stem cell therapies. There's probably benefits for at least some people from these stem cell therapies, but we don't have a lot of assurances around quality control. If there was a mechanism where you could have these experimental therapies available to people who have, consented, who really want it, with some regulatory strategies around quality control for the manufacturing process, the clinical care that these people are getting, I think that actually would be a good middle ground. And maybe we'll get there at some point. Right now, unfortunately, though, we're in this place where people who want these kinds of experimental therapies have to go offshore, where I'm not saying that everybody who's doing offshore medicine is shady. They're not. There are some really good practitioners out there, but there are also some shady characters out there. And it's hard to know which you're dealing with in a situation like this. So, I mean, I think it just is, that to me is a big challenge when you're trying to evaluate the risk reward for something like this. I would say personally, even if there was a small molecule that I was confident could increase follistatin, based on the data that I've got today, I wouldn't say the risk reward favors taking that small molecule, even if it was FDA approved and we knew something about safety, right? Given that it's not FDA approved, you have to go to this, offshore clinic. To me, it just doesn't make any sense. And again, that's why I say I really have to wonder, like, where is this guy getting his advice? Yeah. Honestly, it feels almost like desperation to me.
Really?
I mean, I just can't imagine why a rational person, clearly he's got a lot of reasons to want to, continue to optimize his health.
Yeah.
It's just hard for me to understand why. And again, maybe I don't have all the information, but why you would come to the risk reward analysis that if your goal is to not die, right? Your biomarkers seem to be going the right direction. You would do something like this that at best is going to incrementally move the needle. He might see a positive change in body composition, but the risks that, go along with that, I don't know. And again, you could also say there are lots of drugs that show positive changes in body composition that we found out are really harmful, right? I mean, look at anabolic steroids.
Yeah.
Not that those are really harmful, but they definitely have some downsides to them, right?
Yeah. Fat burners, stuff like that. There's been
right. Dinitrophenol, right?
Yeah.
Lots of people died from that. It got pulled, right? So I don't know. It just doesn't make a lot of sense to me. And I can't, again, I don't know anything about this guy's situation, but I can't help but wonder if this is one of the consequences of, the sort of marketing approach that's been taken here. And, you kind of have to get bigger. When you get bigger, you have to get a little bit more extreme. Like, where do you go from here?
Yeah.
So you did gene therapy on a secret island, right? What's the next step?
Well, his video after this was stem cells. Funny enough, you mentioned that, but which actually seems potentially a little bit safer and more researched.
Certainly, I think there's more evidence for beneficial effects. I think you still have the issue. And I think there are enough of these offshore clinics where they've been vetted a little bit. At least if you go to the top ones, you can be pretty confident. There, though, you still have that issue of they're working outside of the regulatory environment in many cases. And so you don't necessarily know what you're getting, how well it's been purified, how well it's been vetted. Is it really what they say they're giving you? I mean, again, maybe I'm not trusting enough, but I just have a lot of skepticism around these organizations that operate outside the law.
Yeah. What confuses me is just, from my opinion, this felt kind of like an advert for Minicircle. But I mean, we all know his finances and that he doesn't necessarily need money from them. So I feel like he genuinely believes in it, and it's not just a straight up advertisement.
Yeah, I have no insight one way or the other. Yeah.
Should we read this?
So muscle mass had increased by 7%. Body weight also increased by 5%. So a positive change in body, what we would typically consider a positive change in body composition. Again, this is what you would expect from increasing follistatin expression. Again, you could probably get the same effect from anabolic steroids.
Yeah.
Right. Is follistatin safer than anabolic steroids? I have no idea. We just don't know because there's no data, right? Again, this is part of the inability to do a real risk reward calculation. Like, there are a small number of people who have ever had follistatin gene therapy. They were, most, if not all of them, at this secret island, right? Nobody's had this for more than 2 years, I'm guessing. I'm guessing this company hasn't been around for more than 2 years. So we really have no insights on efficacy or safety.
I wonder, similar to what you're doing with rapamycin, we're kind of like, you pay attention to what people are doing sort of experimentally. I wonder if this company is doing that with their clientele. Like, obviously Bryan's an N of 1 now, they can add.
Yeah, I suspect they are. But again, will that data ever see the light of day? I don't know. And if it does, will it be on YouTube or will it be in a scientific publication, right? So but I think it's also, worth appreciating, though, the situation with like off-label use of rapamycin and this therapy, in my view, are very different, right? We have decades of data on people taking rapamycin at different doses for different lengths of time with different underlying conditions. We know a lot, actually, about the risk profile of rapamycin. We know nothing about the risk profile of follistatin gene therapy. Again, that's why I think it's impossible to do really a rational risk-reward calculation in this case. And again, that's independent of the gene therapy technology itself. So there's the cargo. If you think of follistatin as the cargo that the gene therapy is delivering, then there's the backbone, which is this Minicircle backbone. Now, I should say Minicircle, this company, Minicircle, is not the only company that's using this idea of Minicircle backbones. That's being developed by larger, more established pharmaceutical companies as well. But we still have very little information on, what are the potential unanticipated consequences of this Minicircle technology. So one of the advantages of this Minicircle technology, I talked about you've removed some of the bacterial sequences. It also doesn't integrate into the genome. So this is carried outside of the genome. It's called an episome, meaning it's a circular DNA molecule that's not in the chromosomes. And in that sense, it's transient. I don't know exactly how long this lasts, but it's probably on the order of months. So it's not a permanent change to the genome. That's an advantage. That's true most of the time. But in biology, things always go wrong at low percentiles. So without exception, if you put 100,000 of these minicircles into a cell, you will get a few integration events where the circles integrate into the genome just by recombination. And so there is some risk of permanent genetic change. It will happen. There's a pretty good chance when it does happen, it's not going to hit anything important, but it might, right? Yeah. So it's kind of like, you can kind of think of it like, if we have space debris that's re-entering the atmosphere that's not going to burn up before it hits the ground, there's a pretty good chance you're not going to hit anybody's house, but it might.
Yeah. All right.
So that will happen with this kind of technology at some frequency, probably on the order of, tenths or thousands of percentiles. Mm-hmm. But again, we're talking about typically having tens of thousands, hundreds of thousands, millions of these circular DNA molecules in a cell. It's going to happen.
I see.
So we just really don't know what the long-term risks are. And, this whole idea of doing this at an offshore clinic, I don't know. I mean, it's almost inevitable somebody's going to die.
Okay.
There are always adverse events from even the most basic procedures, even in, hospitals that are trying to do everything right. It's almost inevitable somebody's going to die. Yeah. And so the question is, and maybe somebody's died already and we just haven't heard about it, right? Again, that's part of the uncertainty of these offshore clinics is, we hear about people dying in medical tourism. It probably happens a lot more than we hear about because there's no reporting obligations.
Yeah. Covered up. Wow, that's a little scary.
I mean, it's just reality.
Yeah.
So that's why you really do, I would suggest need to try to take a rational risk-reward analysis for all of these things. And to me, this just doesn't add up.
Your final stats. So
this is the speed of aging has reduced even further to 0.64, a new personal best, lower than 99% of all 20-year-olds. So he's referring to the Dunedin pace epigenetic metric, which is thought to monitor the rate of change in health with age or rate of aging.
Yeah.
So a lower number there reflects, in theory, a slower rate of aging. Yeah. And I guess he's claiming that after this therapy, it reduced. I don't know what it was at before, but to 0.64. Again, as with all of these clocks, I take it with a grain of salt. This would be consistent with a positive change. Is it as compelling as positive changes in body composition, which he also saw? No, in my view, probably not. But it's certainly consistent with the idea that this is having a positive effect on at least the epigenetic marks associated with aging.
Okay. And so the 0.64 means in 1 year, he theoretically ages 0.64
years
of a year. Okay.
Yes. I guess my honest answer is I'm kind of uneasy with it. Like, I think it sort of glorifies this idea of going to an offshore clinic to get gene therapy, which, again, I'm not, I've already talked about my concerns about the lack of regulation and having to trust the people at the company or the offshore clinic. That's one piece of it. This, to me, though, just feels like a very an intervention for which there is very limited evidence for benefit and really no information about safety.
Okay. Yeah. Well, it got over 600,000 views, so I'm not sure what it's a pretty big reach, but
yeah. I mean, again, we'll see where he goes from here. I sort of feel like, this idea that you have to keep taking it to the next level. Yeah. I don't know where you go from gene therapy.
Yeah. So I don't know if we can maybe tack this on, but we should probably go through some of the top comments and get your opinion on them. your view. So,
All right.
again,
I don't typically peruse
Oh.
the comment section,
I
but we
live there.
can see what happens.
All right. I'm never confident in a product that produces physical benefits like muscle mass or weight loss when the founders look like they haven't used it themselves. That's kind of mean.
I mean, well, I have to admit, so look, I've heard this comment before. You get this a lot. I've had people, come at me and say, well, you look like a 53-year-old, so you obviously it's not working. Like, I mean, look, everybody ages. There is nothing that's been proven to reverse aging. I've said that before. You should expect that people in general are going to look their age. Okay. So that sort of thought process, I think, is a little bit weak in logic.
Yeah.
Having said that, I have to admit, I sort of had that thought myself when they showed the people from the company and the doctor who was giving him the injection, right? I mean, if they haven't used their therapy themselves, they should maybe explain why. Okay. And again, they look pretty young. They look like they're probably pretty young guys.
They look young, yeah.
So maybe they feel like they don't need to do the follistatin gene therapy. But yeah, they did not look like they have a particularly impressive body composition.
Well, just to back you up, I mean, I'm 30 years younger than you, I think. Is that right? 20. Sorry.
It's okay. Hey, if I was 63, I'd look pretty good for my age.
20 years younger, and you are lower body fat, higher VO2 max. So I'm pretty impressed. And I was a personal trainer for a decade. All right. So this one, actually, I didn't notice. I kind of want to go back. But for a guy who wants to live forever, not putting on the seatbelt is crazy ironic.
I didn't notice that.
Yeah, that is kind of funny. Like low-hanging fruit there.
Yeah.
The probability of this being a scam is pretty high. Did you write that one?
No. Well, actually, I wouldn't say that. So I have no reason to believe this is a scam in the sense that, I mean, I mentioned my former student, right, worked at this company. Like, so I don't have any reason to think that this is a scam in the sense of they are not actually doing what they say they're doing. What I've suggested is I don't think the risk reward at this stage is favorable for this type of therapy.
Oh, you mentioned this. Just 80 more years and we can see if this worked. The suspense is killing me.
I mean, again, this is part of the problem with these kinds of, where the goal is to live past 120, right? Look, the reality is it's almost certain nobody is going to be paying attention to this dude 80 years from now, right? And actually, this is something I wonder about. Like, what's his end game here?
I don't know.
Like, because people are going to get bored. That's why I keep saying you have to keep upping the ante. People are going to get bored with this stuff. And, where does it go? I don't know. And I kind of feel like there's a large number of people who it's just like watching a train wreck because you just don't know what's going to happen next.
Yeah, that's a good point.
I do think it is interesting to consider, like, what does the cosmetic appearance tell us about somebody's health, biological age, potential health span? It's an interesting question. I don't actually know the answer. I mean, I think none of us really know the answer, but it's certainly physical appearance is a reflection to some extent of underlying health status. So there is a connection there. To what extent are we as individuals able to accurately assess somebody's health status based on their physical appearance? Obviously, that's an individual question. There are interesting studies where people have used, AI-based tools to create chronological and potentially biological age clocks off of facial images. And so there, I think you're starting to actually get to something that tells us that there is a real biological connection there, that the neural network can pick up on facial features that are, in fact, predictive of chronological age. Not shocking, but that you can do it quantitatively without the human bias that we all bring to the table. So maybe we should save that for a future episode. But it is an interesting question that that I think is worth exploring. Of course, it is also the case that there are lots of cosmetic things you can do that are purely cosmetic that have nothing to do with your health status that can potentially make you look younger. At least that's the goal most people have. But don't change your underlying biology at all.
Like dyeing your hair or something, or
sure, that's a good example. Yeah. So that's a good place to stop, actually. So thank you all for watching this video. If you like this format, please let us know. If you don't like it, please let us know, and we will take that into consideration when we decide how many more of these to do. But as always, any comments or questions, please leave them below. If you're not yet a subscriber, please please subscribe, and we hope to see you next time on the Optispan podcast.